All right, in this lesson, what we're going to do is look at the actual lengths of curves. And it sounds really complicated, but it's actually one of the easiest formulas that we can get out of calculus. And they can be tricky to work with too. So on all of these problems, the way that I'm going to solve them out, I'm going to go ahead and use a calculator to do the integrating for me. So just keep that in mind. And if your teacher requires you to work all these out by hand and show all the steps, go back and look at some of my other videos for help with some of these things. So here's what we've got. If we've got some sort of smooth curve that begins at A, the point AC, and ends at the point BD, where A is less than B and C is less than D, then we've got the arc length of that curve. And so if you just look at the curve we've got right here, sine x from 0 to 2 pi, we're talking about the length of this guy right here. And since he's curvy, we can't take a ruler to him and just measure. It gets really, really tricky to try and do that. But what we can do is apply a formula. And notice here we've got two variations. We've got one that's along x, like this one is, and we've got one that's along y. So if we want to integrate along the y-axis or have some sort of equation that says x equals, then we can handle that situation with the bottom equation. So we're prepared to go either way. And what's really nice about this is the only math really we've got to do is, it's part of our setup, it's pretty important, is we've got to find the derivative of this guy. So if y equals sine x, we need to know what dy dx is. And the derivative of the sine is cosine, okay? So we're going to take that and plug it into this top formula right here. We're going to plug it into the arc length, which is equal to the integral from, in this case, 0 to 2 pi. And we're going to go ahead and look at it as the square root of 1 plus y prime squared dx, or if you don't like y prime squared, you could have dy dx. Those represent the exact same thing. So here's our initial setup. We've got our y prime. Whoa, that's really ugly. Let me make it better. So we're going to go from 0 to 2 pi of the square root of 1 plus cosine x squared dx. And you'll want to make sure that your calculator is in radian mode, and as long as your calculator is in radian mode, you'll get the correct, and you punch it in correctly, you'll get the correct answer. So we're going to pause for 1 second. I'm going to punch this into your calculator, and we'll see what answer we get. Hopefully we'll match. All right, so if we're going to solve this guy out on our calculator, if you've got the TI-84, you're going to hit the alpha window button, and it's going to take you right to all these choices right here. One of those choices is Finance, choice 4, and we're going to go from 0 to 2 pi. And then we're just going to put in that big radical, so 1 plus, and then the cosine squared. And then lastly, fill in your variable. And if you've got an 83, you can do the same thing. You just go to the math menu. You put in where you start, where you stop, your function, and it should give you the same exact number. So there you go, integrating on the TI-84 for this problem that we're working on. Okay, so for this problem, I get 7.640 units of distance along the sine curve from 0 to 2 pi. All the problems in this section are going to work out just like this. They're really cool. So make sure you got your calculator handy, because it will take a lot of stress off of you trying to integrate the 1 plus cosine squared guy.